based on API 2A. We have here the specifications, not so clear. Okay, so directions, this involves direction. As a minimum, this should include environmental forces in both directions. So this is directions of wave and current attack direction on the platform. So it should be parallel, include forces in both directions parallel and perpendicular to its jacket face, as well as all diagonal directions if applicable. These directions are to be determined at the base of the jacket. So we have determined already the dimensions, length and width at the jacket base. So that's why we have here the attack directions. We have 0, and then we have the diagonal one. So this is theta. And the other side is 90 minus theta. So it should always be perpendicular to the diagonal. So usually, for a square mud line base, it is 8 attack direction because 90 minus theta and theta is 45. No, that's 45. But for a rectangular case, base, like for example, this platform, this is rectangular at the base, most probably there will be 12 attack directions. One on the diagonal and the other on the perpendicular to the diagonal. Okay, so based on API standards. Okay, we will go to SACS file. We will apply these attack directions in SACS input. So we will calculate first theta. So from the figure, this is B and this is L. So we can calculate theta, right? Tangent of theta is B over L. So B over L, we have now the value. This is now the attack directions. Theta in degrees, 0, 0 degrees, 0. And theta 47.2, 90 minus theta is 42. So we have 12 attack directions, operating condition, and storm condition. Okay? So we will go to our SACS file. So this is, we have already done this yesterday. So we will proceed. Go to data file. Okay? And then search the wave. Find what? Just simply type, press enter. So we designate 200 load condition as the operating wave and current 0 attack direction. So we have the wave type. We have already discussed this one yesterday. Is TUC 5th. This is the sorry. Okay, so this is now the wave height. So you notice when you put this one, we have now the wave height at the bottom, see? And then this one is the wave period. So based on design basis, we'll do our design basis. Sorry. We have wave height of 2.4 and 5.7. For storm condition, 5.8, 8.2. So we will consider now minimum water depth. So in here, 200, we will name this one, the first condition. So put an asterisk so that the SACS cannot read that command. You put asterisk. And then I will put operating case, so that's 1 year's term, and then minimum water depth. Okay, and then put asterisk. Operating case, 1 year, minimum water depth. Minimum water depth. Okay, so the minimum water depth is what? Okay. The minimum water depth is 50. So you go here, double click this one. In the crest position, you see, we have 572 ms, na? And here we have still water override. So we will put 50.0. Not 50. You remember the minimum water depth is 50. Na? Okay. Now, this is at 0 degree, right? See? This is 0 degree attack, 0 degree, 0 degree. For orthogonal direction, you should consider MS, maximum shear. Huh? We will recall this one. Do you have the crest position? Huh? This is very important. So if we have now the base of the platform, 0 degree, it should be MS, na? Shear, shear. Orthogonal direction, 90 degrees, 180, and 270 degrees. Attack direction, it should be always to maximum shear, na? Maximum shear. In oblique direction, like for example this one, oblique, it should be maximum moment. Maximum moment. So that's the critical crest position. So say when this is maximum bending moment here, it will be maximum axial force here on this pile, on this pile. So use for diagonal incidence, always use mm. Okay. So in our file, 50, put the minimum water depth as 50, and see, you notice I put ms. See, that's shear, na? That's maximum shear. Okay, next. Copy this one. So we have already 201 operating wave current. So this is at 47.2. So you notice in the attack direction we have 47.2 and 42.8. So we have already calculated theta and then we can compute. So the second is 47.2 and 42.8. Okay. So I will copy this one. I will put my cursor here. Press Control and then scroll down. Okay, to copy. Na? Right click or Control C and then press copy and then put the cursor here and then right click again and then paste. Okay, so I have now copy. Now you can do this in Preside also, but it's much easier for us if we will do this thing in DataGen, right? Okay, so this is 201. I will name this the second as 202. This is 47.2 and the second one is 42 point, yeah? 47.2, 42.8. So I will update this one. 42 point. This one is 42.8. Huh? 42.8. Update the current direction. This is now the current direction. Huh? 42.8. And the wave also should be the same. This should be 42.8. Change this one. 42.8. Huh? So operating wave current at 42.8 degrees. The wave should be 42 direction. And your current should be 42.8. Same direction, to be a conservative. Now, this is 42.8 and what will be the crest position? Here, see? So we have already discussed this one, right? In here. So on the board, If this is diagonal incident, we will use maximum moment. So use mm here. Maximum moment, huh? Follow? Okay. Press OK. 47.2 also is the same. So you will change this one. You can double click. Huh? And then crisp position should be maximum moment. Huh? Crisp position. Press OK. 47.2, 47.2. Now, I will change the water depth because this is minimum, see? Minimum water depth, so I will put 50 also here. Huh? This one, on the wave. Huh? The wave is 50, the crisp position. Go to miscellaneous, the still water override should be 50. 50. So double click this one, no? Wave 50. 50. The water depth at minimum 50. Okay? So press this one, 50, and then at 202, load condition 202, double click again this one on the wave. Go to miscellaneous. The water, still water override is 50. So 50. Okay? So we have done already, save the file. We have done already 42.8, 47.2. What's next? Next attack direction is 90. 90, 137, 132 until 312.8. Huh? So operating minimum water depth. So at 90, so you notice we have the current blocking factor, right? So based on our design, what is basis of design? What is for the diagonal incident? What is the current blocking factor? So here, say current blockage factor 0.8 for orthogonal. Meaning to say 90, or perpendicular orthogonal 90. But in oblique 0.85. So current blockage factor 0.8 for orthogonal and 0.85 for oblique. Oblique is this, the mm, Oblique is diagonal. Orthogonal is head-on 90, 270, 180. Okay? So, we will change the oblique 0.85. So, in here, this is oblique, so it will become 0.85. Right? This is 0, so this is 0.8. 42 and 47 are oblique, this becomes 0.85. So, before any analysis will be done, the basis of design should be established. It depends on client. Now, it depends on client because some clients has a general specifications. So, from general specification, we will take some specifications and then apply it on the project. Okay?
The height weight on 19
2 point?
Height, the height weight.
Wave height. We will check the wave height. 2.4 and 5.7. 2.4 and 5.7.
Wave duration. Wave.
No, it's not. The wave duration is not included here because it's a function, the time, the period. You mean?
And I consider the main wave direction is
This one? No, it's not. It's 0 and this is 90. So with respect to XC, we have these attack directions like this on SACS. 0 is this. This one is 90 and theta, and this one is 90.
I see, but the direction with the maximum high wave.
No. Based on our design basis, see, the wave height is 2.4 and 5.7 in operating.
for all direction wave.
Yes, because we don't have the value in each direction. So we will assume this is uniform. We don't have the value. Oh, okay. If you want to have, I will ask you what will be the value then. So it depends on the design. In this case, we have a uniform. Okay? We have uniform. So some Metosian data, it depends on direction. I see in some Metosian data, 0 degree has different with 90 and 180. Yeah? So in our design basis, we will consider uniform. But if we can change that one in here. So in this case, we will assume a uniform. Okay? So 202, 47.2. I will copy also this one. You notice 0, 90, 180, 270 are the same. 90 theta and this are also the same on the diagonal. So if you copy, make it like this, no? If 90 and 0 are the same, so I will copy this one. Here, I will copy the 200 because it's 0. Right click, press copy, put the cursor here, right click, and then paste. But this is 200, 201, 202, this becomes 203. 203, and double click, change this one, operating wave and current, this will be 90 degree attack direction. Becomes 90, So press OK. Change also the attack direction here, the wave, So wave direction in degrees, that's 90. 90, 90. Press OK. And here the attack direction of the current also is 90. 90. 90. 90. Any problem? So orthogonal 0.8 blockage, and it should be in MS. Shear, shear. So that's very important, That's very important, the positioning of the crest position. Orthogonal always maximum shear. Diagonal should be always mm. So maximum, so say mm, meaning maximum bending. Okay. Another attack direction. So we have already done. We have 132 and 137. This one, right? Okay. So copy what? The same like this, right? 42.8 and 47.2 are the same with that. So I will copy these two. 201 and 202. Press Control. Right click. Copy. Put the cursor at the bottom. And right click again. And then paste. And then change the load condition. So 203, next to 203 will be 204. 204. Here is 205. 205. Okay? So 204 operating current and wave at what angle? 132.8 and 137.2. So this one 132.8. Okay? Operating wave and current 132.8, attack direction, load condition 204. Yes, okay? Change this one. 132. Now, crisp position. This one is 132.8. Now, and the wave parameter, the wave direction 132.8. So I have already, and change this one to 132.8. You can double click or just edit like this, no? Just type. Because you see at the bottom, it determines that that's current direction. Every number here has a value, right? If you put the cursor here, it says at the bottom, see, current velocity. And if you put your cursor here, it determines elevation above mud line. So this one is 132.8. The other is 132.8. 132.8. Okay? So blockage factor is 0.85. Direction is 132.8. It is correct. Maximum moment, no, position. The next is 137.2. 137.2. I have already sent this file, no? So you can check that one. 137.2. So this one. 137.2. Change this. 137.2. Okay. Save the file. And here, change the attack direction of the current. 137.2. 137.2. 137.2. Okay. So the 137.2 at minimum water depth of 50 is already there, So this is operating wave and current 137.2 degrees. Next will be at 180. 180 attack direction. Okay, 180 and 90, 0 and 270 are the same. So just copy the 90. Put the cursor here, press Control and then scroll down. Scroll down. Right click, copy, put the cursor at the bottom. Right click again and then paste. So this is 205, 206. This is 206. Attack direction now is 180. We are at the modeling, so it takes really time. Press OK. Change the angle of attack for this wave. This one is 180. So just put the cursor here. You see its wave direction. 180. Scroll down. 180. Just write. Just type. 180. 180. So after the wave and current, we will use the diagonal, the wind loadings. So we will check the wind loadings. We need only two conditions, X and Y. Okay, next, attack direction, 222.8 and 227.2. 222.8 and 227.2. So it's the same with this, these two here. So 204, I will copy 204 and 205. Control, scroll down. Okay. Right click, copy, and put your cursor here at the bottom. Right click again, and then paste. So 204, 205, 206. 207. 207. The other one is 208. 208. 207. 222.8, no? 222.8. So this one, to 2.8. Okay? Minimum water depth, so that's correct. Change also this one, 222.8. 222.8. Yeah? So same direction for the wave and current. So it's more conservative. Okay? So 222.8, 222.8, 222.8. The other 2 to 7.2. 2 to 7.2. So this one 2 to 7.2. 2 to 7.2. Put the cursor and then type. Once you already master that one, no need to open. Just type and then see at the bottom it's already the current direction. 2 to 7.2. 2 to 7.2. So this is the 8. We still have 4, because this is 12. For a square, automatic 8. Square base at the mud line. So the next attack direction is 270. 270, So for 270, it's the same with 180 and 90, like something like that. Press. I will copy this one. 206. Press Control. Scroll down. Right click. Copy it. Put the cursor here. Right click again and then paste. So I copied 206 because it's orthogonal. Okay, so this becomes load condition 209. 209. Operating wave and what is the direction? 270 degrees attack direction. 270. So I will change this. 270. Another. This one. 270. 270. 270. Okay, so we have now 209. Load condition 209. Next attack, 312 and 317. 312, 317. 312.8. So this is the same with this diagonal. So this is the same with 207. I will copy 207 and load condition 208. So same, same. Scroll down, right click, copy, put the cursor here, so it's repetitions, It's only changing the angle of attack, That's changing only the angle of attack. First one is 210, load condition 210. So this is 312.8. 312.8. 312.8. Just type, 312.8. 312.8. 312.8. So this one 211, 210. So the next will be 211. Operating wave and current at 317.2. 317.2. So this is 317.2. 317.2. 317.2. Okay. So the operating wave, current, and minimum water depth is already defined. The next will be, because in operating condition, we have minimum water depth, maximum water depth. The minimum water depth will determine the maximum shear. The maximum water depth will determine the maximum overturning moment. Maximum overturning moment. Okay? Now, this is quite simple because our loading is simple. How about if there is a tender rig at the platform? Because say, this is quite complicated when there is a tender rig. Like for example, this is the well. You have a certain well pattern. You will put the center of the one well, one load condition, and you have 12 attack direction. Another location of the well, so your top side or the rig will be put on that direction, attack direction in this direction. So you have too many combination. It's quite complicated. So there is actually a way. This is what we call as web search. Web search. Okay. So for this, since we are on basic, we consider basic only. We will not complicate. We will try to avoid complication. So the first is operating case 1 year minimum water depth. The second will be operating case 1 year maximum water depth. So just copy this one and change the water depth. Right? That's the very principle. Okay, copy. So control, put the cursor here and scroll down. See, if you scroll down, there is a limitation on this. See, up to that one, you cannot copy all. So it's a problem. Okay, one procedure is to go to the text. I will close this one. Save first. Save. We will not use this one in copying. We want to copy all. Go to, okay, I have here the file. Click, drag, and then go to edit file. Go to edit file. Drop it, and then go to edit, and then find wave. Find the wave. So in the text file, so I have already here operating case minimum water depth. So I will put the cursor here and drag. Scroll it down. Okay? Up to the 211. No? Up to 211. So up to operating wave and current 317.2. Right click. Oops. Yeah. Right click. Copy. Put the cursor. Take note. Do not paste it yet. Leave a blank. So a space. Leave a space. And then right click again. And then paste. So this is now your file. Do not update here. You got problem. Just only for copying purposes. Much easier here. And then press copy. Save. Save the file. And then go back to DataGen. You can do that. Okay. Go to data file again. Search the wave. Fine. So this is 200. The next one will be. So we have already copied this one, right? So I will put maximum water depth. Maximum water depth at operating condition, meaning to say 1 year. 1 year return period. Okay. So I will change now the load condition. Of course, you will change the load condition. So I will put this 300 series. The minimum water depth is 200 series. The maximum water depth is 300. No? For extreme case, 400 and 500. So we'll put 300. 300. The water depth, now we have already calculated that one yesterday. What is the water depth maximum for operating case? How much? 50.5? Do you have the value? We will check this one. Design water depth is 50. No? 50 plus the maximum tide of 3.3. So it is 53.3. No? 53.3. So this becomes, change only the water depth. 53.3. But here, see, this is mid-height, Mid-height. Right? So 53.3 divided to 26.65. Are you following? 26.65. And this becomes 53.3. You will change only water depth. This is water depth. This is function also of water depth. Right? So, same procedure. I will change the water depth this 40 to 53.3. This one and 2, 26.65. 1/2, no? And 53.3. Yes, of course. No, you change that to 301. 301. This one is 301. This one is 302. It becomes 300 series now, Okay? 53.3, 53.3. This one, 302. Go to 302. 53.3 to 6.65 and 53.3. The next one, 303. The water depth 53.3 to 6.65, 53.3. Okay? So the next attack 132, 304. I will change the water depth 53.3. The mid depth 26.65 and 53.3. The next 305. $53.3 to 6.65, 53.3. $306. So change this one, 53.3 to 6.65. That mid height. $307. $53.3. 308. 53.3. 26.65. So until 311, huh? 53.3. So every day, every meeting, there is a new topic. Huh? 310. 53.3. Yeah.
About the maximum overturning, we will okay, change on.
It's just the same. Because the attack direction is only incident and orthogonal. It's always will change. Okay. So it's done already? Done, huh? So the operating wave, current, maximum, and minimum water depth is already done. So we will go to storm. Storm conditions is the same. The difference between storm and operating is the wave height and wave period. So change the wave period and wave height, nah? Okay, so we will copy. You can copy the operating case, maximum water depth. This one. We will copy the operating case, maximum water depth, huh? Control the 300 series. I will copy only up to 305. Huh? I will copy only up to 305. Nah? Right click, copy, and put the cursor at the bottom. In here, at the load condition, GCK, right click, and paste. Huh? So I will rename this one into extreme case, close parenthesis. This is now what the 100-year storm. Nah? And I will name this as minimum water depth. Minimum water depth. Extreme case, 100-year minimum water depth. So the operating condition is up to 311 series, right? 200 to 300. So this one, I will name this as 400, huh? 400. But I will rename this one into extreme wave, meaning 100 years term, nah? Extreme wave, nah? Extreme. Okay. We will go to design basis. This is the wave kinematics, huh? Wave kinematics, wave period, wave height, wave period, water depth. We will change the value of wave period. So go to design basis. Under storm condition, 5.8 and 8.2 uniform. At any attack direction, wave height is 5.8, wave period is 8.2. How about kinematics? Wave kinematic factors for operating on storm, same, 0.95. So we got no problem with that. And in storm condition, see storm, right? It will change the current speed under storm is 1.5 at the surface, 1.2.9. So change that one also, We will change the wave height and current velocity. Wave height 5.8, 8.2. 5.8 for this. 8.2. What is the minimum water depth under operating condition extreme? Go to the design basis. Mean sea level. So LAT is 50. Plus the minimum tide 0. Plus the storm surge of 0.5. So 50.5. The water depth is 50.5. 50.5. 50.5. Now, the water depth now is 50.5. So, the extreme case, 5.8 and 8.2. 5.5, the mid depth, 50.5 divided by 2 is 25.25. So, change this one to 5.25. This one is 50.5. But your velocity will change, right? At the surface, how much? 0.9. 0.9, 1.2, and 1.5. So see our design basis. 1.5, 1.2, 0.9. 0.9, 1.2, 1.5. 0.9, 1.2, 1.5. Okay? So same attack direction, 0. So this should be maximum shear. Maximum shear. Go to the next case. 401. 401. Change this to extreme. Extreme. Wave. Change this to 5.8. 50.5. And 8.2. Change this also to 5.9, 1.2, 1.5. Change this also to 5.25 and 50.5. So next to this is the maximum water depth. So just copy this and change the water depth. Okay, next. The 402. I will change this to extreme. Change this to 5.8, 50.5, and 8.2. So 5.25, 0.9, 1.2, 4.3, extreme, wave, This one is 0.9, 1.2, 1.5, 25.25. By the way, the 25.25 is one half of the depth, na, as per design basis, that the half of the depth, na, half of the depth is one at mid depth, na. That's why we are using the 25.25. .404 extreme, two, 25.25, 50.5. The velocity will change. .405 extreme. .5.8, 0.5, 8.2, okay. So 137.2, na? 137.2. We still have another, na? So go up and then copy 137.2. So we will copy 180, na? So load 306. Press control, scroll down up to 311. Up to 311. Okay? 306 to 311. Right click, press copy, scroll down, put the cursor on the load condition, jack, right click, and paste. I will change this. .406. 406. This is now extreme, na? .5.8, 50.5, 8.2, 0.9, 1.5. .407, extreme, 5.8, 50.5, 408. So this one is extreme wave. .8. .9, 0.2, 1.5 to 5.25, 50.5. $410. This is 0.9, 0.2, 1. Okay? Done already? Not yet. Okay. So take your time. You just change the water depth, change the wave period.
50.5.
50.5 minimum.
Probably.
The 50.5 is 50 plus the storm surge. Design basis. Always refer to the design basis. Alright. Okay. So the minimum water depth done already. We'll go to the maximum water depth. Extreme case. Copy. So I will copy only up to 406. I will copy only after 406. Copy. Go down.
5 minutes.
Paste. So 411 extreme case, I have already maximum water depth. But you have to change the load condition, huh? So I will name this as 500 series. 500 extreme wave. Change the water depth. What is the water depth? Maximum storm condition. So we have 50, the water depth at L80. 50 plus the maximum tide 3.3 plus the storm surge of 0.5. So 50 plus 3.3 plus 0.5, 53.8. 53.8 water depth. 53.8 water depth. So 1/2 of 53.8 to 6.9. Change this to 6.9. And then it becomes 53.8. The difference only is the water depth. So update the water depth of wave and the water depth of current. That's it. Huh? And also the load condition, of course. 501, 501, 53.8 to 6.9. 53.8. This is 502. 53.8 to 6.9. 53.8. Okay? So this one will be 503. 53.8. Five oh four. 504. Just update the water depth and the load condition. 505. Oops. To 6.9. So I will copy also 407 up to 411. 407 up to 411. Copy. I will change this one into 507. Five, five. Okay, done already? Okay, just take your time.
Wait a minute. My time is wrong. Can you stand for five?
Đi nào? Có gì vậy? So who wants the file also? What? What's up? Yeah, well. Okay? Hmm? You close first and then you restart. No, it's just like this because the very complicated is fatigue. The fatigue really fatigue. It takes time even to run. I say one attack direction is 2 hours.
Yeah.
Ah.
Phải thích lâu lắm, phải thích từng vài viết này.
Web response takes time.
Yeah.
So that's why I think much.
But I think the most important that we need to know how to control the data and find out the error.
Sometimes it is a trial and error. You will see. You run in this LDOC. See, this is create file. If create SACS file, if errors encounter, you have to check this one. You have to check this one and then run the analysis. Still, there is a post view.
Yeah.
And then you can check which one it's not connected.
And during the data then also you may have some typo.
Yes. Just like this. Even this is quite sensitive.
Yeah.
Even if you put this as 8, it's already an error.
Yeah.
Eh?
Yeah.
If you put this 8 and it's too small, you cannot see 8 and G is almost the same. If you run, this is an error. Okay? It's very sensitive. That's why usually using the data gen, it's only load combination. Much faster to just copy and paste. So after this one, load combination. Load combination. So we will combine gravity load. Gravity, which means dead load, live load, equipment weight, everything. Self weight. And then combine with wind plus current and wave. If there is a rig, you have to add a rig and then attack direction. So when there is a tender rig, it's quite complicated. The analysis is quite complicated. So that's why the technique. Say you notice how many attack directions we have? 12. And then we have minimum and maximum motor depth. So 12 times 4 already. So gravity load, attack direction, gravity load. And we still on the model. We still don't have the PSI file. So to check the files, the capacity. Shall we proceed?
Yeah, we stop here.
Stop here and then combination one session.
Yeah, we will try to finish at 7.
Okay.
Because we have 4 days per week, I think, so 5 o'clock. So I'm going to look in half.
Yes, that's a problem. We cannot afford to because they still have the for tomorrow's work.
We try to maintain 4 days per week.
4 days.
Yes, but we should just we today we sometimes we think extend.
Yeah.
We have to start. Next time we should highlight to anybody else that meeting in this room. We also delay.